if you use that Zoom link.
Okay.
You might not have to do it at all, actually.
Okay.
But we'll see.
Cool. Why don't we see anything here?
I'm gonna jam just a minute for the
Okay.
hour, but make sure that you're all good.
Oh,
Yeah,
can I have the Jabra?
Yeah.
Cool. It works. Yes. This doesn't seem to do it.
I don't have juice.
All right.
I don't have high C.
Well, I know
I have like chocolate
that's
milk.
not juice.
I think I have chocolate milk and milk, which is. No, my daughter, like, if she ever gets like a milk, she like takes a sip of it. She's like, this isn't real milk. And then
It's like all
she
sugar.
like hates it. Yeah, it's disgusting.
But then if you're like,
Maybe like juice coffee,
Yeah,
but
I
they don't
think
do
so.
like fountain drinks.
I mean, I haven't bought kids meal in a long time.
I was just mad. All I wanted was
Oh.
icy. Now,
That's like my story.
my
Ask Kelly.
Jay is
I
ruined.
like whole press off.
I was just mad. All I wanted was
Oh.
icy.
That's my ruin.
Jay is ruined. I was just mad. All I wanted was
And I always wanted to do that no less. You know, I need to work, you know, and they make you recycle flavors that you have. And then they always order vanilla.
And they order like the first one.
The first one you said, or chocolate, you know, it's like, seriously, why did you make me say all those?
All right.
I would forget what you said.
So everything's working now except
But that's
the
when they
TV.
don't listen, and then they just say whatever comes into their mind. Exactly
Well,
what
I might have
happened.
just turned
Or
it
did you
off.
turn it
Yeah,
off?
if that lays on,
Okay.
then we're good. It
So
might be,
it might be the wrong source.
The light was just off though.
yeah, probably the source.
Now it changed, yeah.
Best source. Let's see.
Or this didn't pick it up. No? Let's see. Oh, there it is.
Jesse,
Yes.
I'm gonna miss class next Wednesday
Okay. Thank you for
for a
that.
very acceptable reason.
Sam.
No, I'm going to Yankees game.
Cool.
Well, that's way cooler.
Boy, that's super
Okay.
acceptable.
That was good.
No, yeah, sorry, but it was like the only day I just.
No, no, I just think that.
Okay.
Where's the
Hello.
Yankees game?
Are you a Boston fan? Do you
I'm not a baseball fan at all, to be honest.
Thank
It
you.
looks good. That's everything
My boyfriend.
so far.
Okay.
Yeah, but
If there's anything else.
Okay. Don't try to convince me to be a Red Sox fan because I'm a Red Sox fan.
Okay,
and
cool.
it's gonna be
I
so
think
dull
we're all
and I'm
good.
probably gonna break up with you. Yeah. You guys are so much better to have a rivalry. I don't want to be the same team.
Ever since the Chiefs became the Mets, no longer a fan.
Oh,
See if
that's-
these
or
Mets
of
are-
Was that like in the
baseball.
60s?
They'll always be the Chiefs to me. It's like, come on,
Oh, the Chiefs.
Chiefs.
My cousin just got drafted to the Dodgers.
Really?
Wow, that's exciting.
Yeah. Good stuff. He just signed with a big thing.
I am not a huge,
Always carousel, yeah.
So, but that's not gonna change my.
whatever the
affiliation.
Syracuse Chiefs are, what are they, A-ball or triple A?
They're,
Triple
I
A.
have no
Yeah.
idea.
There is no excitement in that stadium.
What?
no,
Yeah,
you know
but
what's the
it's-
most exciting thing? I went to two Mets games this year on a weekend. And there's Memorial Day weekend. I went 2 days in a row. Because they were playing Wilkes-Barre Scranton and that's the
Oh, yeah.
Yankees AAA team.
I see.
It
Where are
had
you
nothing
going
to do with
Yankees?
Syracuse.
Mets Triple A versus Yankees Triple A.
Woo, where's the Yankees, are you going? to
Almost
New
a
York City?
rivalry.
Yeah, we're going.
Oh, cool.
But so my boyfriend works for Make America. He gets like $2 tickets because Clove was like a big sponsor, like the sponsor.
So
And
Lucas, I hope you can hear us in there. Some people might be watching.
Yeah.
All right, how's everyone doing?
good.
Oh, we're good.
Was yesterday just a hectic mess, or did people like it, or both, or what?
That was fine.
feel like I got more done yesterday than I have.
Cool. I mean, that's not common to actually get something done at CoWorks as much as it's, you know,
I don't know if I did it right.
yeah,
It did something.
but cool. Tim, we went through and everybody's project, we started working on a data model. So I need to write down what is your project. And I don't think I know what Elizabeth's project is either. But did you see the videos that Karen posted or the reading? There's a way, we'll start doing this with the chat room app today. But there's a way to sort of start modeling the relationships between the data and then building that out into what's called a relational database. And pretty much everybody is probably going to end up doing that as a way to manage the data for their capstone. So we should talk about, you know, the project that you're working on, the domain you're working on, and how that data model is going to start taking shape. But we'll be doing that pretty much for the rest of this week and all next week, and then you will probably be continuing to work with that part of your capstone right up till the end, in theory, because you might be adding features and things. But anyway, okay, so today we're going to sort of look into the relational database, which is on Monday we kind of had an introduction to what is a database. A database is a server that runs some kind of special data program that's somewhere else, and you connect to that in order to manage your data. And a relational database is a special model where the data is what's called relations. And you would call this a table, probably, like what the official academic papers from the 70s called a relation. You look at that and you say, well, there's columns and there's rows. So each row is what's called a tuple in the actual academic paper, but that's just a list of columns. So, and then the values, it's really the data that's in a list of columns. So every row is one list of values. And every column, so in the same, you know, every place you have a column in your table, you're going to have what's called an attribute. So each of the values that you're saving in each table for every single row is going to be one particular field. This is like the text of a message or the name of a user. And it has a special type. It's a string. You can save numbers. You can save dates and times. You can save like geographical coordinates. And a database will be sort of optimized to work with all of those types of data because that's really what it's meant to do. Okay, so before we dig into like relational databases, we're going to be working with this for a couple days. But let's just review, like there's some other kinds of sort of like databases, or they are databases, but they're not really relational databases. So there's the normal, what we set up Postgres, and that's a relational database. Another kind of database is what's called a key value store. So instead of having like a whole list of columns, you know, a bunch of fields that are for message and a bunch of fields that are for user, and all of this kind of modeling thing where you have many concepts and they interrelate and they have many fields each, a key value store is really more for storing an enormous number of pairs of just two things, and that is the key and the value. So the point of a key value store is really to just be able to be very quick and very efficient at being able to store billions or more of these types of just very simple pairs. And the key is usually a string, and the value is you know, another string or whatever. And you know, it doesn't really have a type or like a set of types. It doesn't have fields. It's just key and value. And the idea is that it can be very big, but it's not easy to, it doesn't have a whole lot of structure. So the reason we're not going to be using this right off the bat is because what your capstones actually need is that structure. You actually start, you need to have the guarantees and the sort of like the organization of many different concepts. In every case, your capstone is going to deal with many different kinds of data, and you would find it very difficult to just toss everything with a key. You could do that. You could toss everything with its own key into a big giant key value store of everything, but it would be very hard to understand and work with once it starts getting big. An example of this is Redis. That's a key value store. Very similar to a key value store, there's a document database. So a key value store, there's the key and there's the value, which is just a string or some blob of binary data or whatever. A document database is very similar, but the value is a special kind of data, and it's sort of like a JavaScript object in most cases, or at least the case where we the example here, MongoDB is a document database where the keys are either strings or anything, and we'll try this out next week. But the keys are strings or something simpler, and then the values are like full-on JavaScript objects. So they can have many of their own fields. They can have and they can contain arrays inside them and other objects inside those arrays. So you can have a whole bunch of data which is structured in any way that you can structure a JavaScript object, all as the value of that key. And that's what makes it, that's why it's called a document database, because the value is an entire document. That's where that comes from. Another one is something for like searching text, is a very different kind of database. It uses what's called an inverted index, and we haven't even looked at regular indexes yet, so I wouldn't worry too much about what this means. But it's sort of a way to pair, you're not looking things up by ID or by filtering by certain fields. You are going to actually make an index that goes the other way, where instead of saying like, give me the text that's at this particular address, you're going to say, give me all of the addresses that contain this particular text. So this is what you would use for searching, like a search engine. And Elasticsearch is like a pretty mainstream way implementation of that.
Where are your slides?
Oh, I didn't post the slides. Thank you. Let me drop those in the channel. Oh man, I'm not doing that. Okay. Okay, so these are other kinds of databases. We're going to come back to this, some of these, and look at them in more detail. But today, we're going to look at relational databases. There are many relational databases. The one we're using with our Docker install is called Postgres. Ones you might hear about are SQLite. This one is a very simple database, and it stores all of its data in a regular file. So you could email your database file to someone else, and they'd be able to actually open it and look at all your data. It's very portable. It's a very nice piece of software, but it doesn't actually work with like many people connecting to it at once and trying to coordinate the writing and the reading. It can only do one thing at a time. So that's the major limitation. And that's why you won't see it on like real big websites very much, but you will see it, like for example, if you make an iOS app and you use the data, it's called Core Data, I think it's like a library for storing data on the device. That actually is going to use SQLite and a file underneath it, because it's just one device and you're just storing database data in a very portable place. So it's very good for that. Postgres is the one we have installed with Docker. It's the one I use at work. It's the one. It's a great database. I recommend it. It's my favorite. It's got all kinds of features. It does all kinds of stuff, and it's free. MySQL, it's another great database. It's free. It does a ton of stuff. I think Max likes this one more, and he might be mad that I told everybody to use Postgres instead. But the nice thing about using this with Docker is you can, if you wanted to, you could just install MySQL in the same way, and it would work almost exactly the same. So they're very similar. They have slightly different features once you get into the more advanced uses of them, but they're very similar. And then two more very similar, but with their own features, are Microsoft SQL Server, they call it, and Oracle, I don't know, RDBMS, Oracle. It's just Oracle database. And they're both sort of like, in commercial use, you have to pay for them. They can get very expensive. they have a lot of features and they're very widely used. So they are like, pretty solid technologies for using, but you don't see them a lot in like open source projects, and you don't see them a lot like unless you're at a more larger company where you have money to throw around on a support contract and everything. And then they're very common actually. So you'll see both of those. But they work very similar, like all of these, the core SQL standard, it's called, the very basic language, and pretty much all of the stuff we're going to be writing this week will work on any of these. So each one has their own like special extensions to it and additional features, but they all support pretty more or less the same standard. So the language we're learning is just SQL, not special Postgres. There's a special extra version which has more features. Okay, so what is SQL? What is all this about SQL, SQL? I don't know the right. I think it's called SQL. I don't think you should say SQL, but some people have like strong opinions on it. And anyway, I call it SQL. It stands for Structured Query Language. It is a typed language, so all the data has types, strings, ints, timestamps, and such. It's a declarative language. So this is. Remember we talked about declarative and imperative languages. HTML is like declarative. You declare what you want to be on the page and you see it. JavaScript is very imperative. You tell the computer everything that it should do in order. You give it a steps to perform. SQL is very declarative. It is very tricky in a lot of ways. Many programmers, like people who work for a long time in real programming, doing real stuff, just don't like it and avoid it, which is fine. You may want to do the same. We're still going to learn about it, but it's just watch. It can be very surprisingly tricky. It can be confusing. It's very math. There's a whole lot of math and theory that goes into it when you really get into it. So it can be very non-intuitive at first and for a long time. So something to be aware of. The good news is most web frameworks, just about anything that's like in use, give you at least one good way to avoid it for pretty much every use case. So if you have a ton of data and you have to do some really complicated operations with that data, or you need something to run as fast as it possibly can with the database, then okay, you might have to drop into writing SQL by hand and taking advantage of every feature in all of these, in whatever dialect you're using or whatever. Yes, you might have to do that, but in all the other cases, you will not have to. I would say it's pretty safe to say that none of you will have to write any SQL for your capstones if you don't want to, except maybe Caitlin, if you want to do latitude, longitude. I'm not actually sure how well that's supported with these kinds of tools, so you might have to drop into using Postgres features. But that's, I wouldn't, we'll see how we're gonna start by doing that way this week, and then we'll sort of transition away from doing it. But you'll see it's not that hard to do the same things. It gets hard when you try to start doing really complicated things. In either way, really, but we'll see. Okay, so here's just like a sample. We saw a little bit of this. Here's just some SQL statements. Here's the first query. You could say, if you had a table of people, and people has name, age, and ID, right? You can say select the count, the number of IDs that are in the people table where the age of that row is greater than or equal to 16, and you want to group by age because you want to see how many people of each age greater than or equal to 16 are in that table, and that's going to print out. We can do like a little. We can try these out. Whoops. We'll try these out in a little bit. but this will give you basically the number 16, and then however many people have that age in the database, or not if none of them have it. And then the number 17 and how many people have that as their age or not. It's only going to be able to group stuff where that age is actually present in the database. So it's not going to say 16, 0 people. It would group together anybody who has 16, and it would give you that number. Here's a way you would add someone to the people table. So you list the columns. We did this on Monday. You don't really need to list out the columns if you know the order of them, but it's a good practice. So if this would be inserting an ID, my name, and my age. And then you could select all the ages, just all the ages. I don't know why you would do this. Or no, you'd select my age, because that's the ID we inserted, I suppose. So that would just give you one number. And you can do all these things, and they're all pretty easy. Like, they all kind of are straightforward, right? They sound pretty like English. This one's a little tricky. You sort of have to understand that you're grouping by one column and you're counting a different column. That's a strange one. Okay, so like all of this, so this is what I mean when I say it's a declarative language. We're not telling the computer, you know, load the array of people into memory, and then for each person in people, do this, and then do this, and then add this number. We're not saying anything like that. We're sort of going at it completely backwards here, and we're saying, I want to see all the data that looks like this from over here. And you're describing basically what you want, and the computer is going to go, you know, loop through the memory or whatever. It's going to figure out how to do that, and it's going to actually do it very quickly. If you have this table configured well, it's going to be doing it extremely quickly, much quicker than something like JavaScript could do it. But you're not, you know, you're not telling it what to do in order. So as you tell it to do more and more complicated things, it's going to get what you have to ask it for becomes more and more complicated. Yes.
What I've been reading when I do the things, so you just do select, give it a name.
For like queries where you just want the data, where you want to just load the data, you don't put this count is what's called an aggregation function. So it's something, this ID in the middle here is the actual data column, but we are passing that column. It's kind of weird. We're passing like one of the columns. It's really none of the data. We're passing just the shape of that data, the column that we're interested in, into an aggregation function, and then asking for the output of that, you know, what that actually becomes when we project it in that way. So this is where it gets very mathy and very, you know, you're projecting data from different shapes into different shapes. Okay, so does everyone kind of understand what I mean by it being declarative? You have to remember these, right? The JavaScript or imperative programming, it's like step 1, step 2, step 3. The computer does each one in order, and down the page is like time, right? You have clock 0, clock 1 microsecond, 2 microseconds. You know, it's going to do each thing in time in the order you've listed it. Pretty much. Declarative programming is like a spell book where you say, zippity zoppity zoop, I want this data, and it does whatever it needs to do to give you that data, right? Now, so here's what I'm getting at. This is like, okay, hooray, friendly English, it's magic, right? Well, this is also magic. We are selecting the number of albums and so we're aggregating together the number of albums that everybody has imported with, let's see, I don't even know. This is going to take a while to figure out. You are joining together the things that people are importing, joining it together with the albums data, we're joining it together with the song data on those albums, and then we're grouping together by the ID and the created at of each person's import of that album. And then we want to know basically how many people have imported exactly one album and when they did it. And all of that is represented by this pretty massive thing with joins and this and that. And this is what I mean when I say it gets more complicated than this. If you want to do, this, there are functions that are hundreds of lines long, or not even functions. There's just statements that are hundreds of lines long, and will take you, and will take an experienced person half an hour to an hour every time to understand what the heck it's doing. So it can be very non-intuitive, but it's a very powerful way of doing it because the database is going to manage all of the bookkeeping and the operations that it needs to do this. Okay, so I think we're gonna get right into some activities with this because I think the theory is great and everything, but like I think you'll appreciate seeing us. We're gonna wire this up with the chat app, so we store all of our chat messages in the Postgres database we have, and then access them through the server. So we'll have a complete example working today. This is a recap. Everybody already did this, right? We got Docker, we've installed, or we've pulled the Postgres image, and we've run the Postgres container. Now, if everybody goes to it, can everybody pull up a terminal? And let me get my VS Code going. Oh, also, I have some code here that I should check in. Okay, let me use VS Code for everything. Because it is. Okay. So I've updated the server with some changes, and I wouldn't worry what they are because we will get into them, but I am going to commit that right now. Set up for SQL in chat room app. Okay, so if you pull into the sandbox from the sandbox repository, you should get in my folder the latest server.js and the package.json, which has all of everything that's new. And we'll go through this very shortly. But does everyone have the sandbox repo working? And does anyone have any conflicts when they try to pull it? You make a noise, Eva?
I did.
What happened?
I'm not sure.
Okay.
If anything happens.
Okay.
So I'm just pulling.
You can just try to discard all changes. You have a whole list of changes there, and you probably don't want to keep any of them. Okay. Try to discard all 9. And then now try pulling again. And as long as it doesn't complain, you should be all good.
All right.
No, you're just pulling. You sure?
Okay. Okay, so everybody's pulling successfully. No conflicts when you try to do that. No changes listed here. I mean, you can have changes, but make sure you're able to pull. And if you go to the server.js file in my folder here in chat room app, this has all the latest. If everybody goes to the terminal now, and if you do Docker PS, does everyone see that? Let me stop this one. If you do Docker PS, do you see this? Do you see a number here and the Postgres or PG or whatever you named it? If you restarted your computer, you might not see this anymore. Does everyone see it? You don't see it? Okay. So basically what you're going to do is this note here. This is what we did. Whoops. This is what we did yesterday to set it up. And this last command, if you restart your computer, you probably want to copy this last command just right out of here and just paste it right into your terminal. And I'll do that myself so that I have the official version here. But yeah, if you don't see it there and you just see container ID and image and nothing under it, paste this into your terminal, run it. It should print out this big long thing here. And then if you do Docker PS again, you should see Postgres.
Mine said it was already in use, which means it never stopped.
Okay, so you probably, if you do Docker PS, you should see the one.
Yeah.
Yes. Okay.
Yeah, I told me to do that. And I looked at it.
All right. I'm gonna run to the bathroom. Help each other get that working. Dana, we need to pull up our Postgres Docker container and VS Code. We're getting started with the activity.
Probably.
And I think it's glasses are working great.
Oh, good for you.
Magic. Yes. Can't read close up anymore. I kept the only glasses for this.
So do you have Docker running?
She's trying to open her sandbox folder. So.
Oh, did you have, sorry, looking at that up. Okay. That's, so, see how that fail. Oh, it's just some remain.
Oh, now I got it. Okay, so restart.
Cool. Okay. So do you remember how you did that Docker, was it run?
Docker PS? Is that what we need to have?
Well, you got to get the if your Docker container is already running, then you do Docker PS to confirm that it's running. But it's not running.
That's all I need, right? Yeah.
Yep, you're good.
Yeah.
Nope. So you would run that after you start the computer, but you got to start the computer first. So a couple more times. There we go. That's what we want first. Then you can run Docker PS and see that's running. Yep. Now you can do that Docker exec command. Okay, there you go. All set.
Alice, do you?
Yeah.
I'm not sure.
Actually interact with
Oh, hey, Alice.
Button second, sorry.
You're okay.
Okay.
I thought I had it here. I don't know if this is ready. Oh, crap. Here, Docker, run. Whenever I run it, it doesn't. I'm gonna go Docker run.
Oh, Docker might not be running.
Okay.
Yeah, so I think you're good. You just got to start Docker. So if you like searching your applications for Docker, you can double click on that. It should start running. Yep, there we go. Once the container stops moving on that, you should be good to go.
Oh, okay.
Yep.
And then just type it in.
Yep, just type it in.
Yeah, I got a nerd.
Every time, you need it.
Yep. That means that she named her container Postgres. And, oh yeah, I guess it's, yep. Yeah, that's fine.
So
Yeah,
let me pull up the,
that means she's inside the container.
the
right?
slides are in the channel for students. And if you don't see, if you don't see
Postgres
Postgres
is
like
just
an
like
entry when you
container.
do Docker
So, like,
PS,
in your
this
case,
last
because you
command
didn't
here,
container name,
it's on slide number 11.
that long string, which is like
The last
container
command there, you have to run that again, basically to make sure Postgres is started up.
I guess it helps name it like what it is, so if you wanted to find it later on, easily you can name it Postgres, but for now it doesn't matter
Yes.
so much. You'd have to kill the container, so you do Docker RM and then the container ID, and then do that Docker run command again.
So.
It's not too bad, but
so
yeah,
on that very last
you don't have to deal with it right
Just
now.
the last one, yeah.
Okay. It has to be that whole thing?
Yep, copy that whole
Oh
thing.
my goodness. All right.
Did you work on it here?
No. Every time I try to copy and paste it, it does this, it breaks it up. I don't know if that's why it's not working.
Yeah, so you
Oh, you gotta copy that all in. Oh,
database.
Oh yeah, I named it something.
I'm not, that,
oh, here.
that's not, it's not supposed to say database there.
I did it before you.
Oh, okay.
Yeah.
So that, okay.
Dekir, if you want to get this working, do a space backslash at the end of the first two lines.
Here.
So after
Yep.
I do that, should I run Docker PS again?
Yes, so from
And then
PS
copy
Code
and paste
Terminal,
that
if you
in.
do Docker PS, you should see
That's how you
that you have
break up
some
a
container ID
command
here,
line.
I do have container ID, I have.
Otherwise, it
but you see
reads
something
the,
underneath them, like a number
the
for
end line
container
tries to
ID
read
and the
it.
word Postgres for
Oh,
image,
okay.
and the word, and it's like, it's supposed to be,
I mean, you can open up the entire sandbox directory if you wanted.
Yeah, how do I do that? Wait a minute.
You go to the menu.
Docker and valid format.
What do you unlock the backslashes?
Yeah.
Oh, I think you have an extra space after that E, or before that dash E, sorry, on the middle line. Oh, also you did forward slashes, sorry.
Oh.
It's the one under the backspace, yep.
Oh, okay. Okay.
Yeah.
okay.
Here, just hit Control C first. That'll clear out what you got in there currently. Then Command V again. Or, Control V, whatever your paste key is.
I think it's Command V.
Yeah, there's still, so there's still 2 rows of titles and 2 rows of values.
What does that
They
mean?
kind of line up. If you skip a line.
That's
you
good,
can
right? I
kind
got
of
Yeah,
see
yeah.
them.
Oh, there. Yeah, it started. You're good.
So, but does container
Okay.
ID
So
go
you can
with
do
status?
Docker
No,
space PS.
container ID goes with this 1F1C thing.
It does.
Image goes with Postgres.
Postgres.
Command goes with this
Okay.
coded thing.
Okay.
Created is that.
So why is
Status
status ports and names in the middle of that?
because if you made it
Because
even
let's say
wider,
it
it
was just like
would be
a
a big long
Docker
table.
exec inside.
And the
Okay.
people who made Docker said, everyone's got huge monitor.
See,
And
So,
so they
Remember,
made
it was
a
like
whole
the
lot of,
cache IT,
so a whole lot of columns when they
All
print
right.
such. Yeah.
let me see if I can
I
get rid
don't
of this.
remember what.
Really, the
So
only
you
thing you're ever gonna need
dash
to do,
IT.
while we're doing
And then you
this
wanna
is
give it the
check
container
that
name?
you see
Oh,
some
sorry,
values down.
the IT is
So
that.
this one's the most
Exact.
important,
Yeah.
and then be able to copy that one. So
Okay.
whatever is under, 2 rows under
Then give
container
it the container name.
Okay.
is the one.
All right, so container goes with that, image goes
And
with
then
Postgres,
space,
and then command
then
goes
slash
with
bin.
this.
Yeah, but these, you're not
BIN,
really
and
gonna
then
need
slash
to.
bash. BAS.
No, like as long as it's there,
Editor?
when you do Docker PS, you're all good.
Perfect.
All you need is the
Wow.
container.
I can't wait till I understand that.
Okay.
Yeah, you'll get there. You're doing good.
Wow.
Okay,
Thank you for the patience, guys.
yeah, this is better to have, so see, I've made my terminal very wide and small text and they all go right across. But it's kind of small, you know, yeah. Does anyone have a problem with this font size in the terminal? We can go to the YouTube later. If you wanna get a, and then get a magnifying glass. You know,
Hey Gus, what did you do to like, shut it off?
I did. So you can do Docker stop,
Yeah, that, okay.
and this will. It says Docker stop requires at least one argument. So see, usage prints out here. Docker stop options. The square brackets means you don't have to include options. This one, there's no square brackets, so this is required. So you could use probably the name here, PG, or the container ID here in that place, and that would stop it. You can also do Docker kill if it doesn't stop and you want to like force it to stop. Docker stop is like telling it to stop and hoping that it stops. Yeah.
Just for future reference.
Yeah. So I mean, you can start it and stop it. When you stop it, you're going to do Docker run again to start it up again.
That whole thing.
That whole giant thing. Yeah.
That's zoomed out, everything is lining up a lot better now.
Cool. Okay. So the one other thing is, let's get everyone, because we want to be able to run this server. Actually, what do people prefer doing today? Should everyone run their own server, or do you want to follow? Do you want me to run the server and I'll provide the endpoint so everyone can try the endpoint? It's really.
Have mine, I don't really care either way.
Okay, if you want to run the server, you're going to want to find your Careers in Code Sandbox folder and be sure you're in the right folder, because to run the server, you have to be in the right folder. So I'm already in the Sandbox folder here. I'm going to go cd Gus cost, and then chat room app, and by ls, there's my server.
So we have to leave the Docker.
No, so Docker's still running. As long as you saw that when you did Docker PS, it's running in the background.
Yeah, mine says like 46 hours, so.
So yeah, you might have had it running since.
You have to leave Docker.
Huh?
If you
He's in Docker right now.
I'm in Docker.
in Docker. Oh,
I got
you're
the whole
already
room.
in the container. Yes, in order to run the server, you have to leave
Or you could
the
split your
container.
terminal.
Or you can split the terminal in half and do the container in one and not the
Okay.
container in the other.
I'll try that.
I think that two pane thing.
Thank you.
Yep.
So do we have to do something either way? I mean, like, where are we now? Is it running on yours?
It is, well, the server is not running on mine, no. And I'm going to start it very soon.
Okay.
So I will keep the server, I will run the server, and the problem with this is there's that, let's see, local, is there a way to persist the connection?
You do like a dynamic DNS thing and then just when a CNAME record at yours, then you just have to change it.
Yeah.
Oh, because the IP address changes, right?
Okay, so I'm going to try to do just set the subdomain uniquely each time. I use a node package called local tunnel, which basically lets you take a port on my computer, and they'll just hand you a DNS record for it.
Yeah.
And it's apparently you can choose what that is. So we're going to try to make it the same every time rather than a random one, and hopefully this works. We will try it right now. So I'm going to do LT. Nobody else has to type this, and this is so that you can connect to my server. So I'm going to connect to 8081, and I'm going to try to ask for the subdomain careers in code. LT not found.
Is that?
Yeah, I guess I'm on a new node version because I'm on a totally new node because of work. Let me just install it. So this is how you would set it up if you wanted to provide the similar kind of tunnel to a port on your computer. So now I can probably do this. careersincode.localtunnel.me. That's pretty nice. All right. Nobody had taken this previously, so that's good.
When you say tunnel, what does that do?
It means that if you connect to this address here that I'm pasting in the channel, it's their website server has an index. I've requested a tunnel be open. So they've created a new record on their server, which is at localtunnel.me, saying anybody trying to connect to the subdomain careers in code, we should redirect their HTTP traffic or TCP. I think it's at the TCP layer. They're going to redirect that traffic to my IP address and the port, and somehow it might open a tunnel, like a secure tunnel, so that it's actually encrypted between their server and mine. But it's going to forward all of your requests to port 8081 on my actual laptop. So if I run the local server on my laptop, then I can basically host something that everybody can see. So I'm actually going to close that, and we'll try it one more time, because what I'm going to do is not have this occupy one of my terminals. I'm going to start it in the regular terminal back here, and then just minimize it, because
Not like I'm not exactly saying.
Do we need to?
It's like a similar principle. Like it keeps a connection.
Right. Yeah.
okay. So that
Yeah.
what I pasted in the student channel should remain available as long as we're doing this example. It might go up and down, but it'll always be that same address. Okay, so I have the server running here. I'm going to terminate it. Now this will probably crash. Maybe the next time someone tries to connect, it will probably crash. So nobody go to it yet. And if I do node server.js here, it says server is running. And here's some new stuff. We're printing out some data from the database right away. And this is because of the code I added. But first, let's just verify that if we go to, whoops, we go to here, we see the user interface that was created. And then if we do /receive, we're going to see an empty array of messages, because I just started the server. So this part, the receive and the send, they're working just as before, but because we just restarted it, the messages are empty again. Now here's some new stuff, some stuff that I changed just today. And everybody should have pulled this down, but we still have Express, we still have this body parser. I've added another middleware called Cores. Do you guys remember Cores from that CORS header thing. CORS is, I don't like it. It's just silly, but you have to do CORS all the time, and I always forget about it. And this is what happened on Monday. People couldn't connect with the UI to this address, this local tunnel, because it didn't have the right CORS headers. So first thing we'll do is we'll try to make that work. What I'm going to do is go to the index page, and I'm going to replace everywhere I see localhost :8081. I'm going to replace this with, everywhere I see HTTP : localhost 8081. I'm going to replace that with HTTPS : careersincode.localtunnel.me. Okay, so everybody should go do this on their own. I'm not going to check this. Actually, should I check this change in? I'd like to leave it alone so that you can run your server locally when you're outside of class. And if you're going to run it locally, you want the local host in all of these places. But I'm going to replace all three of these right now, just so that we can make sure CORS is working and everybody can actually use the browser page if you really want to connect to our server. So I'm going to replace all, save this, and then let's try reloading the page here, and let's see if I can save a message. Did that work?
Does it need to, it's on send/send?
No, so it's just the
Just the
address I pasted
tunnel,
will
okay.
show the web page that Max set up.
Okay, does it need a slash after me?
It shouldn't matter. Okay, so it seems to be working. So if anyone prefers to use that web interface, we are going to keep these endpoints working pretty much as is, but we're going to swap out what it's doing internally so that instead of saving to that array we had, we're going to save to the actual database. And we have the CORS header, so now it's going to work from the web page and all of that. You need that to go to this local tunnel. That's how it's just a hoop to jump through, but it's there. Okay. So the other thing we're going to, the other thing we want to do that's kind of significant is start using the database, of course. So here's, I've sort of made a little data model, which I feel this is going to be the chat room version 2.0. And I've used the proper, the fully correct crow's foot notation here. And you see, like, I usually skip doing these two lines on the one side and the circle on the other side. What this means is that there must be one user for every link to a room, or there must be one user for every message. There can't be a message with no user, right? So there's the two lines here. And on the other hand, this empty circle means there doesn't have to be a message. There doesn't have to be at least one message for every user. There could be 0 messages for a user. And this is by far the most common kind of connection you're going to see in all of your data models. And so I kind of like just leave it out usually, unless there's some tricky thing, and then I'll like forget the notation and write something about how tricky it is or whatever. But this is really the proper crow's foot way. If there was 1 or 0 users, I think there's like there's either a circle here or only one line. And then if there had to be at least one message, there would be no, there would be a line here instead of a circle, right? So that's not true of any of this, though. The user doesn't have to have written any messages. Every user is going to start with 0 messages. We've added a new thing, though. We're going to make chat rooms. So we're going to be able to have, join a certain chat room and chat in just that room with the other users who are posting to that same chat room. So every message is going to have exactly one room that it's posted to, right? Every message will be sent to a particular room. Every message will be sent by a particular user. So let's see, we have both user and room are one-to-many and with message, or message is many to 0 or 1, or however you call it, but it's many to 1 with room and with user. And then users can subscribe to or join many rooms. So a user can have a list of rooms that they can click through, and maybe we'll add a little UI, or we'll just imagine it for right now and sketch it with pencils. But a user could have a list of rooms that they've joined, and they're going to be just listed for that user. And because a user can have many rooms, and each room can have many users in it, we need something in the middle here, which is going to map the users to the rooms. And there's going to be more of these than either users or rooms. I'm calling it user to room because I don't know of another good noun to describe whatever this is. It's a subscription or something like that. But there's many of these for every user, and there's many of these for every room. And each one of these is going to have the user and the room. So we're going to start building out this data model. Does anyone have questions about the data model? Does anyone want to see the fields, like some of the fields like we did with the other one, to make this a little more clear? Or should we just start building it right away?
I think it's better for me if you start building it and then come back and do the fields like as a review.
Okay, we'll do that. So let's just pick somewhere to start here. User table is a good place to start. So what does a user have? Anyone?
Oh,
Name? Yeah.
a first name, last name.
Sure. Not always though. So the first name, last name is tricky because for internationalization, some places what you call a first name is a family name or something, and they switch in order, or the one is. So that's actually very tricky. At our company, our users just have name, and it's just whatever you want. Yeah. But a lot of people expect, especially in America, they would expect first name and last name. So, I would do what is best there, but we could do either. So name is one thing. What does every table have, or should have, unless you know better? Okay, unique ID. Does the user need anything else?
Play a password, log in.
Yeah, eventually. I don't think we're going to make security or logins just yet with any of this, but yes, you'd need to store some way for them to log in. So that probably means an email, and not the password. You don't want to store their actual text of a password because someone could steal that. You would store what's called a hash of the password, but you'd store, something to do with their password so they'd be able to log in. Yes.
Just the text itself.
Well, there's no text on what's the text on a username?
Whoa. Okay, but if I go on here with it says first name, and then I wouldn't just go on and put in my name. I would also have a message.
Right, but that's not going to be a record for every user. That's going to be a record for every message. Yeah, and there will be many of those for every user.
Okay.
Okay, so let's go to the terminal here, and I'm going to go shell into do the Docker thing to jump into the Docker container. And I'm going to copy actually, I can remember it. So we do Docker PS to find the container, and this is just, all, if you make it wide enough, it's a nice table. Otherwise, it's a mess. But all you really need is the container ID here, or this, you could do the name. But I'm going to copy the container ID, which is all the way down here, and I'm going to say Docker exdc. It's already running. It's right there. -it, which means run it interactively and connect it to my terminal. I'm going to paste this, which is the container, And then you want to tell it which program to run in the container. So I'm going to say bin bash. And this sticker, you already did this.
Oh, yeah.
So now my prompt has changed, and I see root at this same ID that was the container ID. So I'm inside the container right now, and I have PSQL, which doesn't work if you run it just like that, because it's going to by default try to log you into the database as the same user that you are on the system. And because it says root at this, it's going to say, well, I'm going to log into the database as root, because that's how it default behaves. That's not how your database was set up. So we need to do PSQL dash capital U and then Postgres, which is the default name of the user for a Postgres database. So we're saying the user is Postgres, and it doesn't even care about the password. I think because, I don't know why, we set a password, but it doesn't seem to care about it. You definitely want it to care about the password when you're running this for real. But on the other hand, you might just rent this from Amazon if you're ever doing it yourself, and all of that stuff gets set up pretty easily for you. So this is just for development. I don't care that much about the password. You definitely should in the real world. Okay. So we have inception, our third level deep. We've gone into the container. Now we've gone into Postgres shell. And we are working right now with Postgres. We can say select star from my table. And it's, of course, going to say relation my table does not exist. Remember, relation is the name for a table. There's a command for Postgres for listing out the tables. It's like,
We call it messages. There's a message.
yeah, there's messages. Okay. So if you do \DT, I think DT means describe tables. And this is a special Postgres command. This is not part of the SQL language, but it's just a command for Postgres to tell you what tables there are that you already can work with. So I've made one called people and one called messages. I don't remember when I did this one, but there's two. And let's see, select star from people. There's nobody in it, but it has, oh, this is the demo. So we can do those little demo queries. Does anyone want to just practice a little bit with a couple demo queries and warm up here?
Sure. But should those have shown up on everyone's?
No, people doesn't exist. So does everyone want to follow
the
along?
Table. Yeah, so that,
Do you want
that's just on
to
you.
follow
Okay.
along? Because there's a step before this.
Okay.
So nobody has to do this if you don't see people. I'm going to say drop table people. This is one of those things to be careful with when you have a lot of data in your table. You don't want to just drop it because you lose the data. So people's gone. Now, drop table, create table, alter table. There's all these commands which let you actually modify the structures that you're keeping in Postgres, to make new tables or change the columns in a table. And these are all, we're going to review terms, but these are called data definition language, or DDL. So there's sort of two kinds of things you can do in a database. One is say there's tables and describe what they look like and change what they look like and alter their relationships to each other. That's DDL, or data definition. And then when you select and insert and you update, that's called data manipulation language. So that's like actually manipulating the data that's inside those structures. So sometimes you'll see DDL and DML and people, spouting those, name dropping those words, and that's what they mean. So we just did DDL here. We dropped a table. We're going to do more of that. We're going to create a table. So everybody should type this one, create table people. You don't need the capitalization, but it's pretty nice. This is going to have open parentheses here. And we're going to describe 3 columns. And I'm not going to do any new lines here. I'm just going to type it right through. The first column is ID, space after that, the name of the column. And the type of the column, so it's always name of column, space, type of column. The type of this one is varchar, which we saw on Monday. This means string. This basically means string. And you can say how long it can be. You can give it a limit. In general, you shouldn't even bother with Postgres because it's designed to like, it's hardly a benefit at all. There used to be people be like, oh, you only need 10 characters, so you should make it only as long as you need the data to be. That really doesn't matter at all in using modern databases. So I'm not going to put lengths on any of these. If you want the database, if you have your intent is to make the database make sure that you can only put 20 characters, you have a certain maximum length, and you want the database to be responsible for that, then you can put a length in here. But we're not going to do that. I just realized I did this wrong. ID is not a varchar. It's not a string. It could be, but let's make it an integer. Let's make it a number, and let's make it a 64-bit number, or as Postgres calls it, a big int. So this is a big integer. It's 64 full bits, 64 switches flipped one way or another. Second column, so comma is after each column. The second column will be name, and this one is a string. So this is varchar. And it can be as long as you want, pretty much. So, and then there's going to be age. And because nobody is going to be more than 3 or 4 billion years old, which is the biggest normal int, we don't need big int for this. We can do regular int. And then I'm going to close the parentheses. You probably want a semicolon, so you're telling the shell your statement is over and it will execute it, and then you hit enter. And it echoes back to you, create table. If it doesn't tell you an error, then it was successful. So if everybody does //dt at this point, you should see messages and people. And now if we do select star from people, you should see 0 rows, but here are your 3 columns, ID, name, and age. So let's try some of these first, you've got to insert some data. So you're going to insert this part. You can skip, but you need to give it values that are going to be translatable to the correct types. So we'll say insert into people. And I'm going to include the list of columns. It's a decent practice too if you don't mind the extra typing, because it will keep you from getting them mixed up, basically. All capital values, and then another set of parentheses. And in this one, we want to say the ID. So the ID will be any number you want. You could start with 1. You want a string now or a varchar, and SQL is a little bit different, and I guess it might be Postgres or all of SQL, but a string, you can't put double quotes on a string in SQL. Double quotes means like a complex name of a table. You can have a table with spaces, I think. For some reason, you should never do that, but double quotes are for other things. So strings are always single quotes. So you want to put single quote, the name you want, another single quote to close it, another comma, and then the last column is age. So I'll put my age, close that second set of parentheses, semicolon at the end, and it should spit back insert 0, 1, which means there were no errors and there should be data now. So if we do up, again, hit the up arrow twice, you'll go to your 2 commands ago. And you can see now there's 1 row and it's the data I just entered. So we can do up again. And now, this is you can hold option and sort of jump back and forth between the words in here. And this will, you could add 2 here, I will say Dakir is 99 years old.
About right.
So there's there's now I've inserted another row. Now one thing that we're missing, there's one very important thing we're missing at this point, and we're gonna have to watch out for this. I put 1 here and I put 2 here, but we have not told the database that ID is unique. It has no way of knowing that whenever I make a column called ID, or we might want to call it person ID, but whatever we're calling it, it has no way of knowing that it's going to be unique. So you could put 2 rows in there, which both have 1s or both have 2s, and that's going to really mess up your whole application because, you know, how are you going to go to those resources? You know, the RESTful path to a particular resource relies on it having an ID. You'll get into a lot of this with Max when you get back to APIs, but the IDs have to be unique for more than one reason. And one of them is so that the tables can refer to each other. And, you know, another is so that people can refer to the data if they're talking to the database. Something has to be unique in both of those cases. So that's a problem right now. We'll solve this a bit later when we get to the chat app, but there's a way to tell the database that this column has to be unique, but you have to say to the database that this column is always unique. And then it will error if you try to insert another 2 in there. But we'll do that shortly. Okay, we've inserted some data. Now let's try this first one. Select count of the IDs from people where age is greater than, let's say, 50 this time. So we've counted the number of IDs from people where the age is greater than 50, and it's given us 1. Now I put 2 rows in here, but this is correct because there's only one person with the age greater than 50. And we're filtering our results using what's called a where clause to give it conditions that have to be true for it to include that data. So if we say instead of select just count the IDs, we could say star, select star. We'll see the full data row that it's returning, which is Dakir. So that's selecting. And then, yeah, you can select a single column, but these are some of the basic operations. And let's use these to make the database work for our chat application. So you can, if you want to, you could say drop table users. Whoops, not users, people. And you could say drop table messages if you want to get rid of it, just so we have a clean. And then if we say \DT again, it says did not find any relation. So there's no tables right now for us to use. All right, now we have a fresh, empty database again. Let's start using our data definition language commands again and start describing these tables we're going to use for the chat app. So the first one is, as we showed, the user table. We definitely need users here. Let's just call it users, and let's add the columns that we mentioned. Let's see, create table users, parentheses, and then list out the columns with their types. So ID space big int, name space varchar, and that's all we really need for now. That's fine. You can imagine it can have all kinds of other stuff, email, login info. But for the structure that we need to make this demo work, this is all we need. So I'm going to close the parentheses and the statement, and we have a table. So we can say select star from users, and it's empty. Now,
For some reason, it seems like I have to type everything in twice for it to work.
Are you missing the semicolon at the end?
No?
Huh, what is it printing when you hit enter the first time?
Yeah, syntax error at or near backslash, but there's no
That's a
backslash
forward slash.
or forward slash, but there's not in there,
Well,
because I just put in the create table.
so you did /DT twice here,
Uh-huh,
and it doesn't recognize that as a command because there's no backslash. So it's waiting for you to end that,
oh, okay.
whatever that is, with a semicolon. And it only errors once you've printed this semicolon, and it thinks the
Oh,
whole
I
thing
see.
together,
Okay.
you know,
All
so.
right.
yeah.
Gotcha.
The backslash, it forces it to do
Okay.
like a special magic Postgres command.
Gotcha.
Okay. So we have a user table. Our first problem, as I just mentioned, the ID is not actually unique, or it doesn't have to be unique. You could end up putting data in here where a lot of people have the same ID. And you could say, well, the application will make sure that it's not the same ID, but it's actually a very good idea if there's an easy way to make the database for like check and make sure that data is in the right structure. It's a very good idea to tell it right off the bat to do that, because then the rest of your application is like safe. You don't have to worry about breaking the data because the database is going to guarantee these things about it. And this is one of the new, one of the all other strengths of a relational database is that you can be very specific about what must exist, what things must be unique, and the shape the data must take. So we're going to do that right now. I might have to look this one up because I don't do this by hand a whole lot, but it's alter table is the command. So it's like create table, but it's modifying a table that we've already made. And the table is users. And then I think the next stuff is add constraint or add unique constraint, but I'm going to look this up right now. So if we go to Postgres, add unique constraint. And in general, if you're confused about any of the syntax or any of the things you see with databases, look for something on Google with the word Postgres in it or with the database that you're using. And in the case of Postgres, the actual website itself, and I guess any of these are going to work the same. So I'll pick 9.4 because it's the newest, but any of these will work. I don't like how Postgres documentation has like all these different versions. Oh, you can jump to the current version. That's cool. So there's a whole article about constraints. You can learn all about constraints. This is probably the best place to learn about Postgres if you are actually interested in this stuff. I don't know if anyone is, but it's very, very well written documentation. And it's comprehensive. They go through all kinds of stuff that you can do. So yeah, these are constraints for creating. So I'm going to go back and say alter table, add unique constraint. Okay, and this here, remember the square brackets are optional and everything else. This is the full, what's called a grammar of how you can use this language. And it's very complicated and there's many, many things you can do with it. But if you get good at reading this, it's a very quick way to see all of the possible things you can do with alter table. So I'm going to look at where action is, alter table something name, and then action, where the action is add something, table constraint. Okay, table constraint means constraint something unique. There we go. Using index name. Okay. Add table constraint. Okay.
Like a really fun Wednesday night.
Yeah. Okay. I never do. This, I think you have to do it in 2 steps. You have to add the index first, and then you have to make a constraint to say that index is always unique. And again, like I never use this directly. I use the magic stuff to alter the database for me, and then sometimes have to look it up every time I write something complex in the SQL. Okay. This person on Stack Overflow is very kind, and they have printed out the exact thing we want. So we want add constraint, and then the name, and then unique, and then the column. Okay. So I'm going to call this constraint user ID unique. And then all capitals, the word unique, and then ID, which is the name of the column that you're putting the constraint on. And it doesn't work. Oh, you need to put parentheses around the column because you could actually make several columns together unique. So you can, this is very flexible. You know, there's a lot of stuff, like I was saying, that you can enforce with the database. One of those would be, well, ID doesn't have to be unique, but ID per state has to be unique. Like if it was license plate and state, you could say, well, both of these together have to be unique. And you do that by listing the columns inside these parentheses. Right now, all we need to be unique is the ID. So we'll do this. We print back alter table. And this has basically added some code and some definition around our table. And every time we try to insert something, and I'll demonstrate, insert into users. And I'm just going to do the 2 columns without printing them first because there's only 2. I'll say 1, comma, Gus. Whoops. Sorry. You need values. You can skip the first parentheses, but you need values. And then I'm going to insert 1 and then Gus's doppelganger. And it's going to say, error, duplicate key value violates unique constraint, user ID unique. Detail, key ID equals 1 already exists. So it knows now that there is something called a constraint. We've added it to this table. That constraint is going to make the database check every single time you want to edit or add data to it, that you are not adding or editing some data into this table that would be not unique in that column. Yeah, so this is like, you know, the one of many, many things you can tell the database to check for you and to guarantee. Okay, so that's pretty much it. Our users table, I think for right now, we could add an index on this. Now, an index is a way to say build a whole library of how to look up where these rows are based on 1 or 2 or 3 columns. And what that does is basically speeds up. When you want to try to find a column, it will have already built like a nice index, just like a library index or catalog card index, so that it knows a place to go look for it. And that it will automatically know to use that index when you do queries and you do selects. And if your table starts to get really big, you know, millions and millions of rows, then having the index is going to make your queries go much faster. So that's another thing you can add. There's plenty of other things we can add. And I'll have a full list of all these terms and terminology. But the one that we want right now is the unique constraint, because this is going to sort of enforce the structure. And we'll do one more, which is called a foreign key constraint. And that is all we'll do for right now. But we're done with our user table. Our user table actually has no foreign keys in it, because if we go back to our diagram here, the user table, every message has a user that wrote it, right? And this middle table here that links together users and chat rooms, each one of those links has a user that it's linking. but user itself has no one of any, it has no one message, it has no one chat room, anything like that. So it has no key that goes to a different table. So we're done with the user table. Next table, does anyone care? Let's do the message table. Let's make just the very basic users and messages first, and then we can try to add rooms if we have time today or tomorrow. Okay, so we're going to do something very similar. Messages have an ID. Everything probably should have an ID. Message has a text. Message has the timestamp. That's probably all we need, right? You could have font or something, but we'll not do any of that. So we're going to do create table messages, parentheses, and then we list the columns. So it's going to be ID, big int. Text is a varchar, and time. I think timestamp, Postgres kind of will complain to you, like timestamp is a word that Postgres uses, but you can totally use it. So let's just use time. Now let's use timestamp. Let Postgres complain, and we'll say timestamp, all capitals. See, that's why it complains, because you sort of have it 2 times in a row. Maybe this is a bad practice. Let's call this created underscore at. And this will be timestamp with time zone, because why not? They're created at Eastern time. Okay, so close the parentheses, semicolon, and we get create table, so it worked. Now we're going to alter this table to do exactly the same as before, make ID unique. So alter table messages, add constraint, message ID unique with the capital, and then the parentheses and the columns that have to be unique. So it's just ID.
Okay, something went.
Wait,
Yes. Oops.
Somehow my Postgres prompt changed, and now
No, it's fine. That's just the end of your statement. Oh,
the apostrophe, see how it's got
yeah,
an apostrophe instead of an equal?
well, so you
Forgot my semicolon there.
yeah.
And then I tried
Oh, and
to,
you forgot your comma and your single
Yes.
quote there.
so what do I need to do to?
Just keep hitting semicolon until it, oh, no. So it's telling you what it thinks you're inside. So it thinks you're inside a string.
Okay,
So just do another quote. And now it thinks you're inside a parentheses. So either do a parentheses, I guess. Close that. That probably means nothing.
Uh-huh.
So, okay, so
I'm back, okay.
yes. If you want, I'll put the commands that we've done
Okay,
just I'll just dump these into
I
Slack.
think it's just the one that I did, the create table messages.
Did you create, because you created table users, yes.
Yeah.
Okay, so it's this one, create table messages. Here, I'm gonna, so
Okay,
that we have a
that'd be
good
fine.
record of this, I'm
Thank
gonna
you.
paste all of these into Slack. So create table users, then this whole alter table users, this thing. And then we have create table messages. And then we have alter table messages, add blah, 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 blah. So that worked. And the same will be true of messages. Everyone has to have a unique ID. So that will enforce that both the user IDs and the message IDs are all unique. That's what we want. Okay. So we're pretty good. Okay, we have messages, but we forgot one column on the message table. Does anyone know which column it is? Yes. So each message has a user ID column, which is going to have a matching value as that user's ID column. So in order to add this column, it's pretty similar syntax. We're going to say alter table messages, add column. And I don't remember if there's a parentheses here. We're going to call it user ID varchar. See if this works. Nope. Maybe it's just one. Maybe it's just one column at a time, so no parentheses. Yep. All right. So I'll keep posting all of the successful ones into here. And if we do select star from messages, we can see now there's 4 columns: ID, text created at, and user ID. Now, user ID is not unique. Oh, and it's not even a varchar. I messed that up. It's a big int. All the IDs are big ints. Here's what we do. Alter table. Sorry, folks.
No, this is
Give
good.
everyone carpal tunnel. Messages, drop column, user ID. Okay, now let's try this again. Instead of varchar, we're going to say big int. Okay. And if we select from messages, we'll still see user ID, but now we know that's a big int, and that's a matching type. So here's another thing which is interesting, because user ID in the messages table is the user ID field unique.
No.
Okay, right, because many messages can all be written by the same user. So we can't add a constraint that says user ID has to be unique, but we kind of do want a constraint that says user ID has to be something. And what that is user ID has to be the match of some ID in the user's table. Like, we don't want to have like user ID, 6,000, and there's no user with that ID, because then it's just, who is that? Nobody, there's no way to like find who wrote that message or display the name of who wrote that message or anything like that. So messages, we want to, and this is sort of what the double lines really mean in this diagram, is that every message has to have a user ID which actually matches at least one user, right? So it can't be null, it can't be an empty nullable column, and it can't be a column that just has any number, because there's no way to know that it matches. So we need to add another constraint here, and this is called a foreign key constraint. So I'm going to look this one up too. Postgres, alter table, add foreign key constraint. Let's just find the answer to this one. Oh boy, here we go. So this is a big one. Alter table. We're altering the messages table. We're going to say add constraint, and we have to give it a name. So this will be it's common to do FK something underscore something. So we'll say messages user ID. That's a decent name for it. And then we do foreign key, and then a parentheses of the column or columns. You can actually have a composite foreign key, which means more than one, I don't know. Anyway, we have one foreign key. We're keeping it fairly predictable and nice. And you shouldn't have to do this composite stuff often unless you have a badly designed database or you have some really weird requirements. And I don't think anybody's going to have to do this kind of thing. But you could make a foreign key on many columns. We're not going to do that. We're going to say it's the user ID that we just made is a foreign key. And then we say it references something else. So we put references. And then this last part is the table that it references, and then the column inside the parentheses that it references. So it references users and then ID. So it references the ID column in the users table, and it's called this, for FK messages user ID. It's a foreign key on the user. It's a foreign key constraint on this user ID column. It's got to reference an ID in this other table. So we close in the command, alter table. Now we're good. Okay, so let's prove that this doesn't, this does what it says it does. If we do select star from users, we have one, or I have one user, my name is Gus, and that's it. So let's say we want to say insert into messages. And then we do values, and I have them listed right here, so I don't need to list them. This will be ID 1, that's fine. It's nobody else has taken message 1 yet. The text will be hello. Created at will be all now. We're just going to use a special function to have Postgres add its own timestamp. And then the last column will be user 999. So we close the parentheses, and it's going to say insert or update on table messages violates foreign key constraint, FK messages user ID, key user ID equals 999 is not present in table users.
Cool.
So this is now guaranteeing that every message has a value here in this user ID column, and that value actually matches a value in the users table. So we've really made a solid version of this part of our diagram, which has got very strong guarantees. And you cannot end up, you know, unless you find a way to essentially hack Postgres, there is no way for this to end up with messages that are for no user or anything. It will not let that happen. So that is that's pretty cool. I mean, that's one of the really cool things. And did everybody get that to actually work and everything? That is
These are really great error messages.
well.
Yeah, that's true compared to some of them.
I mean, this is pretty much any database that's like got this big of a community has been around a while, and it's been polished quite a bit. So they, you know, yes, it has good error messages. It's good to have this to learn them this way though, because sometimes maybe your application will dump some error like this, and if you've never seen a database error before, you're like, what's a foreign key? What, you know? So, you know, they are good messages, but you have to know what it's telling you. Okay.
So I have a question. What is so if for my capstone I'm doing this for someone,
Yeah.
does this require a lot of maintenance? So if his site is up, will I have to?
If they want to change the kinds of, like, the short answer is yes. If you make a project for somebody and they use it in the real world, they're going to come up with new things to change about it. The maintenance will not look like this. I never do something like this. I don't even know the commands for adding foreign keys and everything, because all of that kind of stuff is stuff I do so rarely that I look it up every time I do it. When you do maintenance on like a database like this, you're going to use an abstraction from JavaScript. You'll be writing just JavaScript to say, here are the columns, here's how they relate, go make the database. It goes make the database. If you change any of those, you say update the database, it'll update the database. So there is maintenance and there will be maintenance, but it's not this, it doesn't take this long, or is this manual, if you're, you know, in most cases.
What about like not including like updates or changes, but like say like he's just using his website and people are going to it. Is there gonna be like some like crash or something like that that I don't have to worry about?
Well, if your data model is pretty solid and your application can handle the other kinds of exceptions and it's not going to get hacked, then no, because it won't crash. Like
Okay.
this kind of database will typically just run for years and years and years without anyone touching it. It's possible that it will have a problem, but it'll almost be more likely that the Linux system, the whole Docker system, whatever, will crash before the database does. And in that case, like you're not going to be doing this Docker and setting it up. If this is a real project, you're going to want to put this database onto the cloud. So just click, you point and click and you tell Amazon or you tell Google or you tell Microsoft, you pick a vendor who rents you a database and you basically say, set me up a Postgres, and they all can do it. And they'll be like, here's your Postgres, here's the address, here's the port, here's how you log in. And it will just pretty much run forever. And if you set up these constraints, it will make the data work forever. So that part of it is going to be pretty maintenance free. If you have the actual stuff configured and you have it running on a cloud provider where it's like they are handling bringing it back up if the computer crashes or whatever, then no, there's no maintenance. Yeah, there's, it's hard to say that there would be zero maintenance because, the more complexity there is and certainly the more changes and the more new users you're going to get trying to break it, essentially, the more likely is that it will break. But for a very well-defined problem, if you set it up and you test it well enough, I would say it could run for decades or a long time without ever breaking. That's not unheard of at all. But if you do this stuff right, if you have your data model configured correctly, this whole part of your application is never going to break. And then the rest of it is like, just as long as your API keeps running, you'll be fine. And there's ways to deploy your API too, so that it's sort of managed by Amazon or whatever. And that might be something I'd recommend if this is for a real client and they're not going to have an enormous amount of traffic. Sort of pushing as much of that into like a cloud service where they just say, here's some code to run, here's the database definitions, run it forever, please, and charge me like a little tiny amount of money every time someone uses it. It's not the cheapest way to do a large scale type of thing, but it won't even matter for like any kind of local, like the city doesn't have enough people to possibly use an application enough for it to really matter, and from a price standpoint, and time is valuable. So yeah, we'll talk a lot more about deploying and stuff like that in a couple of weeks. There's a whole week on just maintenance of deploying this stuff. I need a power adapter. Gotta steal John's again. Okay. So any other questions about the Postgres data stuff so far? Okay. All right, so we have two tables. We have our foreign key. We have all the columns. We have the right unique requirements for each one. Now let's use them from JavaScript and hook them up to our server and get that working. So if you see this new code, so this cores, that's for it to work on the cores crap. And then here's a new one. So I've added to the package JSON, I've npm installed this thing called Sequelize. And in the server, I've made some capital S sequelize, which is require sequelize, and it's kind of weird, but there's a capital one, and then there's a lowercase one, which is a new sequelize with the capital. It's kind of from the docs, and it's kind of weird, but whatever, don't worry about it. You can name this whatever you want. Sequelize. Let's do SQL, all capitals, like that. Yeah. Okay. You can name it whatever you want. But this is what the docs have. They name it sequelize. And right here, we're saying new SQL. We're telling it it's I think the first thing is the database. The second one is the user. So the database and the user are the defaults in Postgres. They're both just Postgres. The password is, if you remember from that command, we set password equals CIC. I don't know if that even is necessary. And then after this, there's all this configuration stuff. And you pass it a host, which is localhost. You give it a dialect. So this could be Postgres. This could be any of those other list of SQL things. It pretty much will speak all of them. So you could hook this up to MySQL or whatever. But we're saying we're connecting to a Postgres database. And then pool means this is actually a very cool way to make it much more efficient. So rather than having it connect to the database every time, if you remember from Monday, we had that diagram where it says client connects to server, and then server connects to database and does things for the client. What the pool setup means is that the server is not going to go connect to the database every time a client comes and asks for something. It's going to always, it's just going to connect to the database right away. It's going to connect 5 different times and have 5 different sort of waiting connections just ready to go. And then whenever clients connect, the pool will say, well, here's an available connection. It doesn't have to do all the setup to go find the database and connect to it. So it just makes it faster. Idle means, I guess, how long it stays open if nobody's using it, but it'll reuse those connections and keep 5 of them available. So this means it should be able to handle a pretty enormous amount of requests against a database without crashing or slowing down. Okay, so this is, we've set up a connection to our database. And then to use that, to do things in the database, we do sequelize.query. And we're going to use this query to say select star from messages. And sequelize is a promise-based database library. So do you remember JavaScript promises, callbacks, promises? So sequelize, you can't like say const whatever equals sequelize.query and then whatever dot console.log whatever, because this is actually going to be a promise. So when you say query it, it's going to go do network stuff and give you a promise, and then it will finish the promise later. So we need to do the dot then and pass it the function that we want to run when the promise resolves. You remember this. This stuff is slightly mind-bending, but this is how a lot of things work. So here's our function, which is going to run once our query is finished. Oh, I don't need this part. It's going to run this function. This function is going to take an array of 2 things, because if you're inserting or updating, it's actually going to return you some results possibly, and it's also going to return you metadata, like how many rows you updated or whatever. And this I just got from the docs. They use a thing called spread. Did you use spread with promises?
Not with promises.
Okay, so spread is just a way to say, well, I know this is going to be array, and I don't want to have to put the array stuff there. So you can do this instead. But I'll keep it as a then, just so it's like more familiar, because everybody's seen the then, right? Mm-hmm. Okay. Okay, so we're going to console.log those results as soon as we get them back. The results is the first item in that array. And if you notice, oops, where's my terminal? Okay, so our Docker, we can sort of leave alone the Docker thing for now. But if you notice, when I started up the server, it's saying executing select from messages. So it's actually going to do the query. And it's going to print that right out to the console right here. Now it's empty, so it doesn't have any messages right now, but that is data from our database. That is no data from our database. And that's pretty cool. So if we go over here and we say insert into messages, values, and we say 1, text is, oh, I need to remember the order of the columns. ID text created at user ID. So 1, hello, now, and 1, because there is a user with ID 1. It says insert 0, 1. Now, if we go over to this side and we say restart our server, there's our message. So it read it right out of our Postgres. And that's terrific. Now, for some reason, these are coming back as strings. Oh, maybe, oh, you know why they're coming back as strings is because big ints are too big for, like, you can have a big int that's too big for a JavaScript floating point number. Remember all that stuff about floating point numbers, when you multiply them, they're too big. So it's going to say, you can't even use a 64-bit number properly, an integer number in JavaScript. So it's nice enough to say, I'll just make this a string so you never confuse this with another big int. That's pretty cool. But it is a little weird. It's a number, but it's always going to be in a string in JavaScript land. Cool, very cool. Okay, so that is what happens right here before we even run our server. But what we really want to happen is this should happen when we ask for the messages, right? So I'm going to cut that out of here and scroll down to where we have our app.get the receive endpoint here. So instead of this stuff, where we're just sending that array we had stored floating around in the server, we're going to say, do our query. Send the messages from SQL. So we're going to say, query the same thing, select all messages. You don't need the semicolon. It knows it's one statement, and I do this like superstitiously sometimes, but you don't even need it here. I'm going to leave it anyway, because I'm superstitious. Okay. We have a promise, and we have a callback here. Now, this is kind of weird, because if you notice, like all of our other endpoints, we're just calling send res.send right away, right? We're doing it synchronously. And if we did it in here, well, it's not sending anything outside the promise. It's all in an asynchronous callback. But that's actually fine, because Express endpoints, they expect promises anyway. They handle a promise just the same. You can do a then or call this res.send anywhere you want, inside a promise, inside a callback, and the server will handle it totally fine. It's built to work asynchronously and has no problem with that. So we're going to do the same thing, res.send messages, colon, and then we're going to say results, because that is the results from our SQL query. And not log them, but we'll send them like this. So if we save this, we close our server and restart it. This is why Max was using NodeMon, isn't it? So he didn't have to restart it. Yeah, okay. We should probably do that. Okay, so all it says is server is running, because we no longer have that query outside there. But now if we go to localhost 8081 /receive, we get our data from our database, printed right back out. And we can do this from Postman or Insomnia.
Right?
Yeah.
Is that a JSON object?
Yeah, so Sequelize is sort of like automatically figuring out, like, we are in JavaScript land. We're doing these commands to go to the database and retrieve data and everything. But Sequelize knows to say, like, okay, here's some columns that come back. I'm going to turn this whole row into a JavaScript object and do this for each row that comes back and put them all in a JavaScript array and then give that back as the results, because it's what you want to work with once you're back in JavaScript. Sequelize does all of that kind of stuff for you. You don't have to parse the columns or anything like that. And it'll actually do more for you. We're kind of doing this somewhat, still somewhat clunkily by actually hand typing the SQL here. Eventually, we won't type SQL at all, but we're going to do it at first so you can see it is running exactly that SQL and returning exactly those results.
Where did you went to localhost instead of the tunnel?
Yeah, so the tunnel probably, oh, it's still running, maybe. So you could probably go just like we did. You could probably go to here /receive, and you get the same thing. So everyone should be able to go there. Let me remember to add the other SQL we typed. Okay, so those are the two alterations we made to the messages table. And then, yeah, if you go to this address /receive, you should see the messages. And they are coming directly from the database, which is running in Docker on my laptop. And you can do this in Postman, of course. Get messages. I'm going to replace this get here with here, because Postman is a very nice way to work with this stuff, and it prints it out very nicely for you. And we'll use this local tunnel for everything going forward, as long as no one takes it when I'm not using it. It'll always be this address. So we have send too now. Now send is still going to work, but the problem is send is still saving it to our array. So if we send some, oh, error, unexpected token. Oh, we send it, it says okay, that's fine, and send another one, that's fine. But if we get and receive again, we only see one still, of course, because we didn't save them to the database. We're loading from the database, we're saving to that our JavaScript array. So let's hook up that part. And what we're going to do for that is find the send endpoint. And instead of taking these values and pushing them into Sequelize or the array directly, we're going to find the right place to put them in SQL and then insert them into the right table in SQL. So we need to do that with we actually need to do that with two queries here. So the name is, this one's tricky because the name is not unique. So how do you know you'll find exactly one user with that name? That's a problem. We probably should alter this endpoint so you don't give it name and message. You give it user ID and message, right?
Mm-hmm.
And actually then, we don't need two queries because the constraint will automatically error. It will tell us what happened if the user doesn't exist. So you can try to write a message for a user ID that's not good, but it won't let you. And then we can catch that error and make a nice friendly looking error to show to the people on the internet.
A friendly error.
A friendly internet error, yes. Okay, so we're going to change this a little bit so we hand it user ID and message. instead of just name and message. And instead of pushing into this array, we're going to say sequelize dot, I think it's still query, but I'm going to look up this to be sure. Sequelize query. Okay. Yeah, so it's always just query, and then you give it the SQL command you want to do, and it can be a select or an update or an insert or whatever. So we're going to say sequelize.query insert into messages values. Now we could list out the columns, we really should, but I'm feeling lucky, and we're going to do ID has to be a unique number. Now this is an issue because how does the server remember what's the next ID that it can insert? This is a problem. We're going to have to come back to this. For right now, what I think we should do is, do you remember how to make a random integer? Let's just make a random number that's really big, and hopefully they never collide with each other until we figure out what to do here. So does anyone remember how to do a random number in JavaScript? A random? Yes.
And then dot floor.
Yes. So we do math.floor, math.random, and this has to be, this is between 0 and 1. So we have to multiply this by like something really big, and that's big enough. It doesn't really matter. So this is going to give us an integer between 0 and this. So let's plus 1, so it's at least 1. This will be our ID, const new ID. I don't know the right capitalization. Let's make everything new underscore ID. Just because, but actually, no, let's not do that. Yeah, with APIs it's tricky. With APIs it's tricky because you want your JavaScript variables to be camel case, but API variables are often that lowercase and underscore. Does anyone care? What are people? Should we do underscore or camel case?
I like camel case.
Give us the real world.
You know,
What's
people don't
best?
agree in the real world.
What do
There is
people do
no
on the
best.
streets?
Depends on which street, which city,
Give me
which
the grit.
country. All right, we'll do
Gritty
camel case for the
underbelly.
variables, but we're still gonna return and accept these underscore things with both the database and the API, because that's how we do it at our company, I guess, whatever. So here's a camel case. We make a brand new random number. Okay, good. That's our first value. And in order to do this, we do a question mark, I believe. Replacements. Okay, yes. You definitely want to do a question mark. You do not, you very much do not want to do open parentheses plus new ID plus close parentheses. You do not ever want to do anything like that, okay? If you're using SQL in the first place, just be sure you know what you're doing, and you don't ever want to do that. That is extremely bad to do. Someone will hack your entire database the second you allow them to do that kind of thing. And we can go into a little bit of how to do that, but the basic idea is that this one is okay. This one is safe technically, okay? But that's because we generated this. If there's ever a time when I say message, right? Okay, give me the message and plus message, put this right into a SQL command. Well, I can make message be message, close quote, close parentheses, close semicolon, select from passwords, dump this into this, delete all your data, close command. And then it's gonna just run all of that as if it was the SQL. So that's, you know, this is like a horrible, horrible thing to see or to do. Never concatenate your own strings together and then give them to a database. You're asking for trouble if you do that. So that's why there is a convention in every single thing where you can run queries like this. There's something that is like for replacing values. And this will be a safe way to do it. it will know not to allow someone to end the command and then do a bunch of malicious stuff in your database. So we have 3 values, and they are ID, message, the text of the message, and then this one's always going to be now. So we can just put that right in line. We're not substituting anything. Okay.
Okay.
So and then
Question mark now.
question mark, comma, now, empty parentheses, close all of this parentheses, and then semicolon. And rather than ever concatenating anything to a database string, you pass the values for this.
Can you post that on Slack when you're done?
Yes. The link to this? Or-
Yeah, that thing. Yeah.
Okay. Yes.
Semicolon, quotation mark.
You pass the values after it, and in this case, it's replacements and either named, so you can, ooh, this is nice. Never mind the question mark. Let's not do the question mark. Let's name them. So let's say ID, text. So this is how this particular thing, this SQLized library allows you to substitute in values into your queries safely. So we make it a named thing, and then we use this thing, replacements, and you use the same name here as you use after the colon, it looks like. So we're going to do this, and then we're going to say, oops, here's our text, here's our query, and then our replacements are ID, new ID, text, request, body, message, or text, or whatever, but we'll keep it message, I guess. Oh, and also we have one more column. We have user ID, right? So there's one more substitution. User ID is request.body.user ID, right? And I don't like how they have these on different, all on the same line. So I'm gonna put this in its own little organized thing. Close this thing. Okay. So that's a pretty big function call here, but we have our query text. It has 3 substitutions, ID, text, and user ID. After this, we put the object, and this is, I got this from the docs. It has a option here called, I want to replace with these things. Because they're named, it's a dictionary instead of an array, and each one matches the name here. And then we put the values from JavaScript that we want to include in this query. And what this SQLize is then going to do is actually get a connection to our Postgres, safely substitute each of these for the places where we indicated where we wanted to place it in our SQL query, while preventing anybody from hacking the database and deleting the whole thing. And then actually run that just like we ran our commands with our directly in the database. So it should do all of this, and then we're going to return OK. But let's do a then, so that we only return to the user once the database is done. So we'll do that in the same way that we put a promise and did a then after the select. We're going to do a then function, and this one takes what, results, comma, metadata, and this function will contain this last part, so where we send back the OK. And let's, while we're in here, let's do this console.log. All right, let's delete the messages push. But while we're in here, let's just log what we're getting back. Console.log results and metadata. Let's see what those are. And then we send back OK. Yeah. OK, so generate new random ID. run this query thing, pass it the text with the substitutable values, and then this specification here for where those values are coming from in from JavaScript land. And then this is going to give us a promise, and we attach a then to it and run this thing once the promise resolves. This gets these two items, results and metadata, and we're going to log them and return OK. Okay, so let's see what happens if we have to restart the server again manually. Why don't I see the terminal? Server is running. All right, so if we receive, we still receive. If we, oh, Postman. Let's do this from Postman properly. If we receive, we still receive. If we send, it just sits there forever and does nothing. Okay, so, well, you know what I think happened here? This is not a good message. It doesn't have the user ID. It has the old format. And we have a then here, right? But we don't have anything catching. A promise can reject, right? A promise can have an exception and reject. And probably what happens is when we send in message and user ID, we have message, but user ID is undefined. We didn't include it. So it's going to put none there. And the Postgres is going to say, well, there has to be something here, and it has to match something in the users table. So it's going to just basically say, no, error. And then Sequelize is going to see that, and it's probably going to reject the promise rather than resolving it. So we're going to put a catch here. And we'll put a function here, which has an error. We'll console.log that error. And then we're going to send status error. And I think you'd want a code that's not 200 here or 201. You'd want a code like 400 or code some error code. But let's, oh, hey, it printed the error right here.
Mhm.
Unhandled rejection. That's exactly what happened. User ID has no value in the given object. Blah, 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 blah. So I guess maybe Sequelize caught this. It knew that we didn't have a user ID defined and we were trying to insert it. So maybe it didn't even bother to send it to Postgres. But in either case, we did it wrong, and it definitely wasn't going to go through to here. It ends up having to be caught. So we'll have to do this pretty much for everything in order to make queries to the database and handle the successful case and the error case. It's going to be just like a promise, then, and a catch. Okay, so let's restart again. And let's, someone's arguing about something very serious. Okay, let's put, and look, we get status error. And this thing should probably have, oops. This thing should probably have logged pretty much exactly the same thing. Yep. So we didn't log, or we didn't end up with an unhandled rejection. We ended up with it logging the error that's from the rejection properly. But it's the same thing. Named parameter has no value in the given object. Now you're going to want your API to be a little bit more friendly than that. It should return like JSON that says, rather than just status error, because this is all the client's going to see is status error. You probably want this thing to respond with something like, you need a user, you're missing a user ID field. And there's various ways to do that nicely with APIs, but I'll let Max get into that more than we're going to do in the next couple of weeks. So we're just going to say status error is good enough. We're building the server, and we can check what the log is every time for now. So name is no good. We need user ID. And this probably can be either one or the string one. I'm not sure, but let's see. Put status OK. So it's actually working.
But now, wait a minute. on the form,
Yeah,
it says name, first name.
yes. So the form is going to be interesting because how is it going to know which user is sending the message?
Right, because we haven't acquired a login.
Yes.
Right.
So maybe let's, I might just update the form on my own rather than, because I don't want this to spend a lot of time this week on doing the forms and doing this, because you're going to have a lot more time on that, adding front ends and adding APIs to this. So I might just update that form to be compatible on my own and then let everyone know there's a pull, you can pull the GitHub. If that,
Okay.
does that make sense? Okay.
And when you say form, you mean?
Like the
when you,
actual HTML form.
yeah, the front end that
Right.
Max made.
Oh, okay.
So right now, oh, we have undefined, undefined, undefined. Fun. Why is that? Did we change the format? Oh yeah, so we're printing out all kinds of different formatted stuff. Let me update the web page front end so that it's compatible. What you'll end up doing is putting a user ID here rather than the name, right? Because there's no way to, you're not logged in or anything. You have to basically tell it which user number to look up.
Can you get it to generate a user ID invisibly so that you're still putting your name in? But
We have to make some decisions, because if you put your name in, does it make a brand new user with the same name, or does it find a user that matches that name and use that user? Maybe it should do that. Maybe we'll make it so it does the second one. But like, if you logged in, you would have to basically save what user you are. And then actually it would have to check that you're allowed to post messages as that user ID. So that's a whole security and authorization part, which is probably Max will be doing that. And yeah.
why did we have to switch to user ID instead of name? In messages?
So
wait a minute.
it's because the guarantees that the database provides are not like that the name is unique, or
Just
that
the user ID,
just that
right.
the user ID is unique. And there could very well be two different users in two different chat rooms,
Mhm.
which have the same username, but are different users and should see different messages.
Mhm.
So we really have to define what is unique in the system. And we've made the decision that name is not unique. So it's really, we would have to sort of cut some corners somewhere in order to only require you to add name. Or we have to be logging in, and so it already knows the ID that you are. And you don't even have to put name, you just type the message, which long-term is how it would work.
Mm.
So here we have a put.
Oh, I had another quick question.
Yes.
What did you take out of the code before? Because I looked away. The message, wait a minute.
I took out the
deleted
part
some
that was
message.push?
messages.push, that
Just
whole
delete
call.
that whole
Yeah.
thing?
Because that's up here and we're no longer using it.
Got
This
it.
is completely not used anymore because we're loading and saving both from the database.
Okay, I thought that was it. I just want to make sure.
Oh, unless we call this save thing /save, in which case it's going to look for that thing and it's going to save it to a file. And we don't need this anymore because we have a database to do it for us. So I'm going to delete that
Okay.
entire save endpoint.
And the console.log messages, that comes up too
Yes.
on line 70. Okay,
Yes. I'm going to check this in. So
I'll pull it. Yeah, okay.
yeah. And just you might have to discard your changes first if you're editing the same file.
Oh, okay, yeah.
Okay, so that's pretty cool. We have a full database, it's connected. If we do user ID 2 and try to send a message as user ID 2, it's going to say status error. And that's because
We don't have it too.
we don't have a 2. And this time, we're actually going to see a database, a true database error because, whoa, this is a huge, it logged out this huge error. Name error, severity error, detail, key, user ID equals 2 is not present in table users. So this is the message directly from Postgres. And SQLize has sort of bundled this up as an error object. And it's rejecting the promise and saying, you got an error. When we tried to query this, do this query for you, it got an error. And there's a whole bunch of stuff. Man, look at this. SQL, the full SQL it tried to do. So you can do all kinds of logging. The table that it was trying to insert into. Anyway, that's very cool. It has all the same constraints. It is our database, and it follows all the same rules. And it will, if I quit the server, like, so if we do receive the messages, we have 2 now. And this one, look, this one has our random ID, so that's working. As long as they don't collide with each other, it won't complain about the unique ID. So we'll get away with that for long enough, I think. But we have 2 messages here, which is good. This is the one from, I think that's the one we made directly in the database. If I close the server and then I restart it, the database hasn't gone anywhere. So I can go right back to querying from the database. The server can forget everything that it knows every single time someone requests from it. You can reboot the server, you can make 4 servers, and you can have them, you know, alternate requests or whatever, and they don't need to actually remember anything. As soon as they're running, they're just connecting right to the database, and the database is good. And not only that, but we did this in Docker. So normally Docker would shut down and wipe out the whole container, everything. But we linked the Docker to the folder. Remember we did that, like make a folder and link the folder to something in the Docker. So we have an actual folder on the laptop itself, which is going to stick around. And so tomorrow, if I rebooted my computer and I had to restart the Docker database, it's still going to find the same files. So those aren't going anywhere. They're pretty safe. And I feel pretty good about that. So that's it. I don't know if I want to, let's maybe not get into building out the rest of the model today. Does anyone have questions or want help with their data modeling today? We didn't even take a break.
Yeah.
Let's
take
just,
a break.
all right.
Can we just end?
I'm sorry, folks. I forgot to take a break. So much fun with databases. We didn't
Fun
even
with
take a break.
databases.
I think in lieu of, that's good.
Okay.
I hope everyone had fun. This is a really cool part, and there's
Yeah.
no more tedious crap like Monday in the next 2 weeks. It's pretty much all fun stuff like this. So that's good, right? That's much better than Monday. Anyway, I think in lieu of the break, we'll end early today. And if anyone has any questions about their models, or the homework is work on your data model, and also there is some more, do some of these activities if you can. These are like SQL activities on the internet. If you want to get some SQL chops, really they're both extra credit, but just try them out. These are really easy to run, and they set up the database and all the data for you. So you don't have to do all kinds of like shenanigans with Docker. They're a very nice way to just try the SQL syntax. So
how will we be setting up our capstone? Will it be with Docker?
No, I don't think so.
Okay.
I think it would be good to start developing it with Docker. So that's actually a good question. I would recommend work on your data model, work on the concepts and the diagram and everything. I would not go try to build your tables just like we just did today in the actual Docker, because that's really not the best way to do it. This is much more for learning than it is for like a practical thing you want to do. I would say next week, we're going to get into what the ORM is. That's the full SQLized. That's what's called an object relational mapper. And that allows you to define your data model without ever writing SQL at all. So it's much more maintainable in general. If you really like this and you're like, I want to write the whole thing in SQL, you can go ahead. That's something I've seriously considered and would do on a hobby project, if I was allowed to. But it can get very much harder to maintain. You're working at a very different level, and you're going to be doing a lot more boilerplate and sort of grunt work than you have to. So I would recommend, hold off on actually trying to build it until we do the ORM approach next week. It'll probably be by Tuesday. You might be ready.
Okay.
Anyway, that's it. Thank you and goodbye, YouTube.
Are you gonna update your sandbox and push it?
Yes,
Yeah.
yes.
I'm just, cause I like kind of like,
Updating the sandbox.
I tried to, but then it got crazy.
Yeah,